Hello
Hello
everyone.
everyone.
We are here. We want to present our research. The title is Solving the Pacman Games Using Backtracking and BFS Algorithm. Let me ask the authors. My name is Yusron Ananjan Pidimpinan. You can call me Yusron.
My name is Salsa Bidarnaldi. You can call me Salsa.
We are from Informatics International class, batch 2018.
What is Pacman? Pacman is one of the most popular video games developed by Namco and released by Midway in Japan May 22nd, 1980. In Pacman games, the player should walk through maze and eat all dots to finish the game. Also, the player must avoid colliding with the ghost to keep alive. As we know, Pacman is the most popular video game of all time. In the first year, Pacman has made 1 million US dollars. Initially only in the arcade, but Pacman has now been released on other platforms such as Game Boy and SNES. According to the programmer Toru Iwatani, invented the Pacman based on the missing slice of pizza on a baking sheet. Since Pacman is the first game that used main character, it created Pacman culture, which is called as Pacman mania. In Pacman game, player must control the Pacman character through through a tortoise maze while eating small dots and avoiding the ghost. If all dots along the maze run out, then the game is finished. In this research, we make a Pacman game more simplified. Thus, there are no ghosts, and the things the Pacman the character need to do is eat all the dots in the maze, and the game is finished.
And how to solve it? We use two algorithms right here. First one is backtracking algorithm. Backtracking algorithm is based on DFS, depth first search, which will explore possibilities. The other two is maximum route. Backtracking algorithm will check which roads have been passed and which roads can be passed in this Pacman game. For the implementation of backtracking algorithm to solve Pacman game is save all the steps. Therefore, we use a stack to save all the steps. And then how to Pacman check which roads can be passed. Uh, Pacman can pass the roads if there is a dots in Pacman direction, up, left, bottom, right. Or in mathematical way, it's like x y minus one, y plus one, and x plus one, and x minus one. It will check the from the Pacman position. And for the second algorithm is BFS, but versus is a graph search algorithm. This algorithm is used to reach the endpoint from the starting point. BFS algorithm will be do search sequentially, starting from the adjacent or network first before moving to the next level. And for the implementation of BFS algorithm in the to solve the Pacman game, Pacman the Pacman character will do BFS if there is no dots around him. So if there is no dots in his direction, y plus 1, y minus 1, x plus 1, x minus 1, then it will do a BFS. And then from the problem detail, also.
In the problem detail, we provide two types of the maps to solve. The first map is all dots connect to each other, and the second map is not connected to each other. As we can see in this first map, all the dots is connected, and the second map is in the middle of the map. There is no dots, and we can see the difference between use backtracking algorithm and BFS algorithm to solve this game.
And here's the way we solve it. First one, the problem solving. In here is we use the first type of the map, so which is all dots is connected to each other, but we type for the backtracking. finish the demo. So we use HTML and JavaScript to implement it. Okay, right there is no dots in the up like that, and then it will be back to the start. And if in the way of the Pacman back there is a dot, and it will go to that direction. And there's no dots, and you'll be back to the previous tab that's already set in the stack and found it. I'll be back again to the previous tab, which already stored in the stack. Why it's not go here? Because it's the use backtracking, so it will be back to the previous tab and finish the game in 49 seconds. But how the BFS algorithm works, as you can see, maybe for the beginning it looks same, but it will use BFS algorithm if there is no dots around the fragment. Around it means only in the x plus y, x minus 1, y plus 1, y minus 1. Up, left, uh, up, up, left, right, bottom. Yeah, right up. You can see right there. But unfortunately, it spent more time to finish the game. It's about to finish. And it's finished in 56.001 seconds. And let me try for the second type of the map, right here. Second type of map, which is there's no dots, which is the dots is not connected to each other. So we're back to the, because there is no dots found here. And it found something on dot. And because there's no dot, then it will be back to the previous step until Pacman initial position. But it cannot solve it. Backtracking, Pacman cannot finish the game of second type of map by using backtracking algorithm. But how BFS? Let me see for the BFS algorithm. Okay. Even there is a hole, there is the dots is not connected to each other, but Pacman can finish the game of second type of map by using BFS algorithm. Why? Because backtracking algorithm is used save all the steps in the stack, but BFS algorithm will do search if there is no dots around him. Use the BFS algorithm. Yeah. Oh yeah. BFS algorithm is also used stack to save the ground searching. Right? It's the ground searching. The gray ground is the searching. It will save the step. Okay. Then it can be Pacman finish the game of second type of map by using BFS algorithm in 55 seconds. If 55 around 55 seconds. And then for the time profiles, we comparison of time complexity. Uh, right here in the graph, we only compare when we use the first type of map because backtracking algorithm cannot solve the second type of map. As you can see right here, if the dots is 20, then backtracking algorithm can solve it around 20 seconds. The FS algorithm can solve it around 60 seconds. And if the dots is 30, then backtracking algorithm can solve it around 30 seconds. But the FS algorithm can solve it around 111. And right here, if the dots is 40, then backtracking algorithm can solve it around 50 seconds. And the FS algorithm can solve it around 130 seconds. And if the dot is 50, for the both result is pretty close. For backtracking algorithm is around 50 seconds, and for the BFS is a bit higher than the backtracking. It's around 50 seconds to, but a bit higher. And then for the if the dodge is 60, then backtracking algorithm can solve it around 70 seconds, close to 80 seconds. But for the break for the BFS algorithm, it can solve it around 100, yeah, around 2 minutes.
Okay, based on the graph in the first type of map, the result of the backtracking algorithm is always faster than BFS algorithm. The average time of the backtracking algorithm is around 43 seconds, and the average time of the BFS algorithm around is 19.6 seconds. For the second type of the map, we can compare the both algorithm because the backtracking algorithm cannot solve it.
Okay. And then for the conclusion, in this research, we have used two algorithms to solve the Pacman game simplified version. Both algorithms use the backtracking algorithm and BFS, versus algorithm. The results show that in the backtracking algorithm, Pacman can walk through all the paths in the maze containing dots if the path have a dots and pass before. But we conclude, and then we already conclude two statements. First, if using first type of map, which is all dots is connected to each other, then backtracking algorithm is more efficient and more stable than BFS algorithm. Second, if using the second type of map, which is the dots is not connected to each other, then BFS algorithm is more efficient rather than backtracking algorithm because backtracking algorithm cannot solve the second type of the map, which is when the dots is not connected to each other. Then the references to do this research, thanks to both of them. Then yeah, thank you very much,
Thank you for watching.
and
Goodbye. See you
goodbye.
again.
See you.